I think I've learned a lot since I started my space project that I've been working on for 4 weeks. Um, I've learned enough to where I think it's time to take a break and kind of start re-architecting everything. I still have the implementations of a bunch of the materials and a bunch of the noise and stuff that I'll be able to port over. That's going to make it much faster. But the whole framework of randomization and stuff I want to change in the project because I at one point had an idea about nested parameter randomization, and last night I learned a little bit about structs, and I think they're really good friends of each other. And basically the idea here is that instead of using one random stream, I'm going to use three, but they're going to be responsible for randomizing different parts of the randomization scheme, and each one is subservient to the one above it. So we have three coordinate systems that I've spun up here. I can just show that, and we're using the game instance for that. Now we're going to store universe XYZ, galactic XYZ, local XYZ in three streams. This is going to be a struct though, or at least the universe location is going to be a struct, and probably the random streams will be a struct. I'm going to do that here in a minute. But the idea here is that these three can roll a random stream that can randomize the universe properties. These three roll a stream that randomizes the galactic properties based on a subset of the universe properties, and these three will randomize the local properties based on a subset of the galactic properties. This ends up getting us 998 to the 9th power of different randomization capabilities. That would be 998 to the 9th power. It's a lot. It's a lot of coordinate spaces for us to randomize from. And since they control different things, we don't have to worry about like unique seeds controlling this versus this versus this, because they're controlling like different pieces of the randomization. So an example of that would be, so there will be one struct at the top level that defines universe parameters. The universe level defines the galactic parameters. The galactic level defines the local parameters, and the local will randomize within the nested sets of parameters. So let's go ahead and start some structs. We'll call this universe coordinates. We'll go in here. This is going to get... So I didn't know what these were, but they're basically data interfaces, which is something that I could have used a long time ago, and another reason why I'm kind of on the re-architect train, because I should have been using these all along. And then here in a minute, I'm going to start working from the top down. So the difference here is that my other method was bottom up. We look at the solar system first. We generate that based on the coordinates. And this new system is going to be top down. We look at the universe first. We figure out its coordinates. Then we figure out if you're in a galaxy or not. And if you're in a galaxy, then you'll have certain properties of your randomization for the next level down. And if you're not, then you will have different parameters. And then we'll figure out if you're... So this will determine if you're in a galaxy, this will determine if you're in a cluster, and this will determine which star you're at in a cluster. And each of those levels will have its own parameters like age, energy level, things like that, that determine the randomization parameters of the cascading parameters of the levels underneath it. So we'll just go ahead and save this. Great. And now we can go back to here. Get rid of all this. Not yet. I want to replace location from seed, get seed from location. So this inverse coordinates struct inverse coordinates. Go delete. And then I think I can just split struct pin. Yep. I don't like the name. We'll call this master coordinate. We'll take this as, should I just call it coordinate? Okay, and then there's one thing that I forgot in that struct. We also want multiverse seed. I love multiverses, so let's call it oh my god, I can't believe I didn't know about the struct thing. This is like, we need one more plus here for each one. And then we feed this in. this in and this in, and then we mod mod by the max 32-bit int. That's how we control the multiverse. All right, there's our seed generator now using a struct. I don't think I need to return a struct here. And then likewise, oh shit, that's right. I don't think this is a thing. It seems like it's too hard to reverse it once you start modding stuff with it, you know? Like, you could add it back, but I don't think that fixes it. Like, we added it, and you could then, but then we modded it, and that's the problem. The mod is the problem. I'm sure there's a way to mathematically reverse that, but I don't think I actually need this function, because I'm pretty much always going to be dealing in locations within, like, all the math and stuff. I would almost never have a seed without a location first, so we're just not going to do that. Seed from location turns multiverse. It takes a multiverse coordinate structure. It returns a trio of seeds. This will also take a multiverse coordinate structure as an input. This is what's going to handle swapping between locations. Wait, why am I doing this? I don't need this anymore. I don't need this anymore. I don't need this anymore. I just need, oh my god, it makes it so much easier. How do I collapse my pen again? Recombine struct pen. See from location should take a multiverse coordinate. Oops, I was working on the other screen. My bad. There it is. Bam. Oh, it makes everything so much easier to be using those structs. Okay, and then we, after that happens, we initialize the random streams to a new seed, and this is what's going to handle actually like changing the location. I'm not sure if this is good enough. Like my end goal for this rearc is to, I have some ideas on how I could implement a method of traveling between systems that doesn't require load screens or anything. Just you go faster and then you get to the other systems, you know, like you just speed up and you'll get there. And I think that idea is a good one. I don't need any of these. But we do want one of these. No. And then here we would create like an event. Let's see why it's upset. Oh, it's not. It just works now. Universe random stream, galactic random stream, local random stream. Should I just... No. We're going to use this type of camel case everywhere. That's one kind of pet peeve that I had on my last iteration of this, is that because I was learning as I was going when I started it, which I knew this would happen. Like, I would want to redo the project after I understood a little bit more about what I'm doing. But because I was learning when I was doing the project, there's a lot of shit I did wrong, and there's a lot of shit that I'm probably still going to do wrong, but I understand it better now. And having the ability to do something like this, where you can collapse, like this alone is huge. Like, just being able to do my own data interface definitions. Okay, so this is an example of how I get my seed. It's the same logic for each coordinate system, which makes sense if you think about it. In fact, nodes. Chords. X. Y. Z. I should have collapsed it to a function, huh? X. Y. Z. There we go. Seed from location. Wait. I guess it doesn't actually matter. I mean, it does, sort of. X. I'm kind of curious why all these got shuffled around. So we multiply and then add the salt. We add the three together. Then we add the salt. And then we mod. Okay, there it is. So save that little function, go back out to get seed from location. Now we need to rewire things. See, salt. Oh my god. Beautiful. Excellent. Everybody looking good. Everybody looking good. Alright, there she is. Save file. So part of this is gonna be like actual just like science fair project level research about different classifications of different scales of the universe. Because we're gonna base it on a little bit more of a real world approach this time. Let me see if my work GitLab is back online. That's going to be a problem if it's not. Alright. Well, my actual job GitLab is down today, so I can't really do anything. So here I'm going to do like to do broadcast location change event after random streams initialize. Leave this here. So now we're going to be controlling the location of the player at the game instance level, which means that everybody's going to have access to it. Everybody's going to have access to the 3 random streams. Everybody's going to have access to the current multiverse coordinate. We're going to have the ability to set the multiverse coordinate, and then when that happens, it's going to broadcast an event to everybody that cares that the randomization change, which should be pretty much everybody. And then we're going to recalculate everything. And this is all part of the idea I had about swapping between systems without having to like do a warp effect or anything, just driving there. A long story short, the idea is that within a certain rate, like you define a boundary in world space. Let's say I say that my universe, so you have about 80 million kilometers in a extra large game world defined coordinate space, a double defined coordinate space, in either direction. So you actually have about 176 million kilometers to deal with. So we're just going to arbitrarily say that at 8 million kilometers, or not 8, let's say at 70 million kilometers away from the origin, we're going to start the transition on any axis. So, and over the next 10 million kilometers, we would warp the skybox to the point at which it would be 50% the new system skybox, 50% the old system skybox. This is not counting the stars. This is like nebulas and stuff. By the time you hit that 80 million kilometer boundary. And then when you hit that boundary, we can reset the world origin to the center of the new boundary. So if you were at 80 million kilometers on the x, after we figure out the math to reset the origin to the new segment that you're entering into, you would be at negative 80 million kilometers on the x, right? But you're in a new block of space, and the same would be it would be the same for all three of the coordinates. And as you're moving closer to these edges, we're warping between the various skyboxes. And the one thing that I'm not sure about is like how to make the stars move properly. That's still kind of a mystery to me. I'm not sure I'm going to do that yet. Because like for like nebulous skyboxes, lerping will look fine because they're already designed to be like recombinated. But for a star field, a lerp is not going to look right because you're going to have stars like disappear while other stars are reappearing. They need to move. So we're probably looking at some sort of particle system or something along those lines. But I'll figure that out a little bit later because like this is all this approach that I'm doing here is going to be top-down approach. We calculate universe parameters first. We calculate galaxy parameters next, star cluster parameters next, and then star cluster, and then star parameters. And we're talking about the star parameter level. We're not there yet. So let's see. We have our functions. We have the ability to set the location, which gets a seed, takes a coordinate, sets the internal multiverse coordinate to the new coordinate, gets the new seed from the coordinate, and initializes the random streams based on that. And then we want to figure out dispatchers at some point to dispatch a location change type event. And that would be the trigger for our destroying of one solar system and respinning up of a new solar system. So like each it's sort of like a pseudo octree but without unnecessary levels, because to get the kind of coordinate space I'm looking, I would need like 36 octree levels or something like that. So with this, we skip that. So imagine that this, oops, that's not very good. All right. So just as an example of the type of coordinate system and to like clarify it in my own mind of what I'm talking about, imagine this is our universe coordinate space. Right? And we divide this up into 4 blocks. So what we're going to describe is actually an octree, but we're dividing it up into many more blocks. We're actually dividing it up into 998 blocks on each axis, but it's easier to demonstrate the concept with just 4. Alright, there we go. So, say this is our universe space. Then, if this is 0, 0, this could be defined as like 1, 1, 1, negative 1, etc. So, then this would be our universe space. Then the next coordinate system down does the same thing, except it works on this block level. You get the idea. So you have another smaller cube. And now you're dealing with this cube, right? Okay, so this is divided up by the second coordinate system. Coordinate system 1, coordinate system 2. We do this again, and we end up with a block that looks about like this. And this is our coordinate system 3. So if this is determining where the galaxies are, this is determining where the star clusters are within that galaxy, this is determining where the stars are within that star cluster. This is where it gets fun, though. This is also divided up into, well, in our case, 998 segments on each axis. But for sake of illustration, we're just going to assume it was 4 or 2 coordinates on each axis. So you're going to end up with this. This is your scene space. This is the actual space the player lives in. Everything else are just abstractions to help us do things like re-origin the world when they cross out of the box. So my idea from this diagram, working with this level, which is what I was talking about, the 88 million kilometers wide or whatever radius. So my idea here draw another spatial cube. Except this time we're going to draw a neighboring cube as well. Alright. Player is here, and they start moving in this direction. At some distance from this side on the x-axis, we begin a transition phase with the intent of it hitting a 50% transition as they cross. As they cross this axis, we're going to reset the world origin from the center of this cube to the center of this cube. So say our cubes were 50 million kilometers, then that would mean you're resetting your world origin 100 million kilometers to the positive x direction. So now, if you were at plus 50, after the origin reset, you're now at minus 50. But that's good, because now we could let this, the edge transition, handle the remaining 50% of the lerp between skyboxes. And now, by the time you get right here, your skybox is this space's skybox, and your sun is this space's sun, and we've destroyed this guy and replaced him with just like a particle placeholder. And through this manner, you could allow the player to have like two modes, like an afterburner mode for inside of a system travel, and a warp mode that we would put some level of like heavy restrictions on. Like it's definitely going to be a fuel limited thing or something like that. But to cover these guided scales, you would use your hypergalactic mode or whatever your third travel mode is to drastically increase the player's speed to make transiting this 80 million or 50 million kilometers or whatever take, let's say, for a given star, it should take 2 minutes to fully traverse the cube from one side to the other, right? So we figure out whatever speed it takes to go 50 million kilometers in 2 minutes. We set that as the max warp speed. And then we let, since these are actors, the entire solar system is an actor. I was thinking, oh, I can only have one. But that was mainly because I was tying my skybox and everything into the solar system, which I don't need to do. The skybox is a game instance level probably thing, at least the parameters for it, because we want to be able to shift that around regardless of the state of the solar system. And then what it means is that the solar system is just a star plus planets, a star plus other objects. So we control the skyboxes externally. That's what's going to let us do this kind of warping stuff. Then the solar system, what I want to do now, instead of like going out and building something, I want to define it first. So like that's what's about to happen actually. Let's just start by example on defining the stuff. So we're going to start at the universe level. And we will go to our content drawer and we'll go to our structs because these are going to be structs. So I'm actually going to make a folder here and we're going to call it coordinate layer I'm not sure I like the name, but we'll start here. So we can, I already know the structs I need. So struct universe parameters, galactic parameters, stellar cluster parameters. Local system. So everything that I want to randomize for each of these layers goes into these parameters. So again, we're starting at the top now. So what kind of properties what are the oh fuck, there's a database term that's called universe parameters, so I can't just seek that. Fundamental properties of the universe. Perfect. This is the science report part that I was talking about. The like 6th grade science project. Space, time. Okay, age. Age is a good one. Matter, density. Matter, density. Energy. Let's go with something that's not actual physical universe property. I mean, it could be, maybe. Multi-years. I mean, who are we kidding? It probably is, but... And I already started switching naming conventions here, but I'm going to kick this. I'm going to nip this in the bud right now. There we go. Integer. Okay. H, matter density, energy density. Start location. Player start location. Or initial multiverse coordinate. This is like the player's initial spawn location along with the multiverse seed. Because remember, the multiverse coordinate has the multiverse seed in it. I don't know if I like the name. So if you were like traveling between multiverses, you could land in different places, and things like that. So you have age, matter density, energy density, player spawn coordinate. Motion, I can't do motion at this level. I don't think it's just too complicated to start talking about like inflation. Energy, light. Classification of the universe. All of space and time and their contents, including planets, stars, galaxies, all other forms of matter and energy. I mean, that's pretty final. I'm assuming that should roll up. Or does it? I guess technically that doesn't roll up the multiverse, because all of space and time would be local to a single universe rather than. So it's still small. And it's probably fractal, so. Awesome. This is perfect. So this is next. I think this is what we're going to go with for now. So let's talk about galaxies. Oh, enum. I'm going to need an enum. How do I? Oh, okay, see. I see. Got this. Spiral. spiral. I don't need this. Great. Okay, so we know we're going to want a classification. We know we want age. What do we have on the universe? Age, matter density, energy density. I think we're going too complicated with this. We're just going to say density. And then here we can also have density. Age, density, player spawn coordinate. Classification, age, density, color. For when we want to render galaxies, we'll need to know what colors we want to make. What else do we need to know about the galaxy level? The color primary and secondary will form the tint of a lot of the stars in the system too. Like, we'll push the colors towards those directions. Is there like... Would it make sense to put redshift here? Would that be calculated red or blue shift? Would that be calculated? Just thinking. We need another struct. Do all galaxies require a black hole? Is there a supermassive black hole in all galaxies? Center of virtually all large galaxies. Observational evidence indicates that almost every large galaxy has a supermassive black hole at its center. Feature of most galaxies. So I think we could go ahead and say that if it's an elliptical or a spiral galaxy, size. Oh yeah. Okay. We want a vector. These are display parameters. Now we need that struct. Age, density, luminosity. Or should I just use density as like a master for spawn rate and luminosity? I think I'm just going to use it as a master. It's a little easier to control. And it is a video game, even if we're getting pretty detailed here. Supermassive black hole. Yeah, okay. And at any of these layers, we could render stuff. Like at this layer, we can render things based on this layer. At this layer, we can render things based on the next layer, which is going to be stellar clusters. Stellar cluster classification. Globular open. Okay, we need a new enumeration. Okay, got this. Where's my cluster struct? So we know we want this. Classification. I think everything's going to pretty much have age, density, color primary. Like, these are actually all the same, except for this. Age, density, color primary, color secondary, local offset radius. Age. I really wish it highlighted that. Density. Local offset. Oops. Oops. For secondary. What, age, density, color primary, color secondary, local offset, radius. Factor. Radius is a float. Something like this. Embedded cluster is another. I want them both to be able to be embedded. I should probably hang on. There. Keep me from having to. So then we're going to need system parameters. We can call it local. I'm fine with that. I just want to rename all that shit. You know? Oh, hey man, I didn't see that you were in here. Yeah, there are plans for Milky Ways. I'm re-architecting the project. I got warp tunnels working, sort of, in the other project, and I, I think that like I always knew that it was going to come to a point, especially using this as a learning project, to where I would want to like rebuild everything again, not from scratch. I'm going to recycle everything that works really good. But like I just learned about structs. I could have been using structs the whole time. It would have made everything 10 times easier. Like that kind of stuff. You know what I'm saying? And I have a lot of good stuff. Like all the math is good. And that's the hard part. So I'm like, I started a clean project. I'm doing things a little differently. Yeah, just now. I mean, I knew about structs from C, but I didn't know about them in the context of like blueprints. Yeah, and I have some ideas for like a little bit cooler way to do randomization and things like that. Like I've changed my coordinate system for this is now a struct. It's right here. You have universe XYZ, galactic XYZ, local XYZ, and a seed for the multiverse layer. With these three, instead of using longs, I'm using just the regular N32s. Yeah, like I feel like the pieces, like not, I'm still gonna use a lot of the stuff from the other one, but I want to like because it's really not that much work to put the framework back in place, and if I do it the way that I'm doing it now, I think I can have a much more like robust, not just at like the solar system level, but like at the universe level, a much more robust universe. Like right now, you would be able to zoom out to any of these levels, right? So like if you're here, then you would be looking at galaxies. If you're here, you would be looking at star clusters. And if you're here, you would be inside a star cluster looking at a star. And then from within that star, that's your local space, right, in the actual game. And I was actually drawing some stuff from my own perspective. But I think if I do it this way, I think I know a way to make it so that you can fly from one star system to another in like actual space without having to do like any kind of loading tricks or anything. And the idea is kind of like a treadmill of cubes around the cube you're in, and then when you approach the boundaries of one of the cubes, you start caching the cube that you're going to transition into, and you start transitioning like the skybox and stuff. And so like you have a predefined point in local space, and let's say when you get within 10 million kilometers of that point, you're going to start transitioning like the skybox to the next cube skybox till when you hit that point, it would be at like a 50% transition. And then what you do at that point is you rehome the world origin to the center of the new box that they just entered into. So they would swap from, let's say you're at 50 million kilometers of your boundary. So you would swap from 50 million kilometers. We rehome the origin over here. Now you're at negative 50 million kilometers. You let the remaining part of like your boundary lerp between skyboxes take care of the rest of the fade as you fade into the new system. And now you're approaching like a new star system, and you didn't have to do any kind of loading or anything. You just flew over here. And the great thing about this is, let's say you make it take 2 minutes to cross one of these systems, you could have them fly forever, right? And just be like basically streaming the next system in ahead of where they're going as they approach it, and streaming out the system that they're leaving. And then it's like interstellar travel become like local system, like local cluster interstellar travel just becomes you driving but faster. Like so you have your boost for like in system driving, and then you have another more powerful boost that will probably put some heavy restrictions, like definitely a fuel cost and things like that on, so that you can only boost so far before you have to refuel. And that will allow us to travel like within our local like star level XYZ. And then for like the other levels, I'm going to use some form of like warp gates. Like you're not going to be able to do that with your ship by yourself. You're going to have to go to like a location in your local cluster, or like locations that contain stargates, and you're going to have to go through, you're going to have to like set some parameters here and go through that to come out in like a different part of the actual like universe or galaxy. But like interstellar travel, I think we can handle in real time. We don't even really need a warp tunnel, if I can figure out a good way to do it that way. But this is part of the reason that I wanted to do it this way. And then the other part was this idea that I had, or actually I got from a comment on one of my YouTube videos, that I researched some stuff, and it was talking about a completely different way to go about this process. Like this is kind of like a No Man's Sky-ish way to do it, and he was thinking more of like a top down, and I'm looking at like a hybrid now. So the idea is this idea of nested parameters. So to give an example, at the universe level, I have age, density, and the initial player spawn coordinate. This corresponds to your multiverse coordinate, and that allows you to control the seed of the multiverse in addition to like where the player comes into the universe at, right? So that's like, this is like your top highest level possible place. Hang on, I got a text message. So, but then I can take these values and I can use them the next level down in the randomization of the galaxy parameters, right? So, like, age of the galaxy would be some function of some percentage of the age of the universe, right? Density would also be some randomized function around the density of the universe. These will be specific to the galaxy. This is like your size of the galaxy. This is your local offset when you're rendering it. So like when you're at this level, you don't want everything to be on the exact integer coordinate points. So this is like a float offset from your coordinate point that lets you get like true randomness in their locations. And then you have like a classification enumeration. So here we have spiral, elliptical, and irregular, right? So if you wanted to, say, have a star map that you could zoom out of from star, if you wanted a star map that you could be looking at like a local star level stars, and then you could zoom out of that and see local star clusters of stars, right? And you could zoom out of that and see galaxies. These randomized parameters will give us what we need to do. Like, they won't actually be changing the space. We won't actually be changing the like coordinates, but we'll have what we need to render like a galaxy. Like, if we can like, we have to build that still, but we have what we need in the like framework to plug into that with one day I'll go out and I'll be like, how can I build a procedurally generated, like, good-looking spiral galaxy from a distance, right? Like, you don't have to travel through it because it's like a map-level deal. And then you could double-click that galaxy and zoom in, and now you see the star clusters. And it'd be like, how do I make a procedurally generated star cluster of this type, of this type, of this type? And then you could double-click one of those clusters and zoom into that, and now you see the star systems. And then you could maybe select a star from there and go through the Stargate and end up in that part of the universe or something like that. And to do that, I need these nested definitions of randomization properties that interact with each other. So like the universe parameters will have an impact on how you randomize the galactic parameters, will have an impact on how you randomize the black hole parameters for the galaxy, will have an impact on how you randomize the local or the stellar cluster parameters, will have an impact on how you randomize the local system parameters, which will have an impact. You see what I'm saying? No. Actually, this is fine. So, another good thing about this is I'm logically breaking out things that shouldn't have been connected to each other. For instance, in my other project, I bound the skybox to the solar system, but I should have never done that. The skybox should be like a game instance level thing that you transition globally, and that gives you the ability to drop in multiple star systems without changing the skybox, right? And that would be like a part of moving between star systems. I can't move between star systems if every time I spawn a star system, I'm going to get a different skybox. I can't do it smoothly anyway. Local system parameters. Hang on, we're going to need some more structs. I don't have to actually define them yet. But I do, well, I don't have to actually, like, enumerate them, but I do need them. So, let's be like, planet parameters. Also, the sphere noise generator I made to get my nebulas is going to make way better planets than my little nanite planets with some material offset in high density, like spherical meshes. It's gonna, I think it's gonna, I can do like really cool stuff with that, because I can also put in like crater layers to the randomization of the noise for the planet, so that like I could have one layer in there that has like big craters and one layer that has small craters, and then we're randomly picking from all the textures. So sometimes on your planet you would get big craters, and sometimes you would get big craters and small craters, and sometimes you wouldn't get any craters, and stuff like that. So planet parameters, we're just going to define it. We're not going to put anything in it yet. So I know I'm going to need an array of planet parameters, a single star parameter, although I could use an array of star parameters if I wanted to have binary and trinary systems. Why not? It doesn't hurt me for them to be an array. Instead of this, we'll do star parameters, but an array. And if it's empty, it just doesn't have a star. Star parameter array. Same thing for planet. Stars, planets. Yeah, sure. Yeah, you can. Sort of. I mean, you can have the material always face the player, but you can't. It's not going to change the direction the mesh that the material's on is facing. So, like, if you put it on a sphere, it might work, but you can't. You can't do it like you wouldn't be able to make. You wouldn't be able to make like a plane always face the player with a material. So the way you do that is you make the plane always point at the player, and then you have whatever material you want on the plane. So there's actually, I think it's like find look at rotation or something like that. There's a function that you can take the plane. Planes are on a dragon's face. At least the glow of the eyes. Is the dragon's face 3D or 2D? Because, like, if they're... No, like, you could do that for sure with spheres. So... Just, I think... Glow is flat planes. Yeah, but I don't know if you would necessarily try to copy WoW at this time. It's like it's a very old engine. Is your dragon head 3D or 2D? Like, are the eyes in an actual like 3D dragon head? So like, boop boop. So, like, say you have a little dragon boy, a little derpy dragon boy, right? Sure, in a minute. Let me see if this helps you. So, for his eyes, you can create a sphere. You look up how to make an eye texture, eye material on a sphere, and you just have that point out the z-axis, right? Have the iris of this, point out the z-axis, right? Stick those in his head. There's thing 1, just the eye glow. Sure, yeah. Go ahead and link it. I'll take a look. But then you would just find look at rotation and clamp that within like bounds so that his eyes aren't rolling around in his head. So you would say like, oh, it can only go like, you need like a max and min pitch yaw roll for it, right? And then you just use either the max or this if it's under the max and rotate the eye with that rotator. You can whisper it. Or actually, how about a server link? Because I don't look at Discord very much, man. I don't know how good of how useful exchanging the ID would be. Is it like I think I probably know what you're talking about. They're doing the like classic. They're doing the classic like disc with some kind of glow sprite of an eye on it that always faces the player. Probably a spherical glow if it's always going to face the player. Right? And then they're layering that over the top of the dragon. So it's like just probably just outside of it or just underneath the mesh. So to do that without a particle system, you would do the same thing I was talking about. You make a disc or a plane. You find look at rotation and you rotate it to face the camera on like the event loop. You have to like you can't make the material do it. Like the material only provides you the texture. You have to make the mesh do it. Oh, I think I don't even see hand touch. And see hand touch. Yeah. The mesh does it. If this is what you're talking about, like the classic thing where you have like a sprite texture on a plane, and you want it to always face the player. I am human. Wow, these captures are getting intense, yo. It didn't want me to just find the blocks with a plane. It wanted me to find the blocks with a seaplane. Log out. It's not. Hang on. Discord. Yeah, sorry, I'm having difficulties with my Discord right now. I don't really want to slog through reactivating my account. But the if what you're talking about is like the thing on a flat plane always pointed at the player, you have to make the plane point at the player manually, or not manually, but there's that thing I was talking about. It's yeah. Find this guy. You see this? And this is going to take a location and another location and give you a rotation to have whatever's at this location look at whatever's at this rotation. And then you just have to get your axes right in your object so that whatever axis this is using aligns with the part of it that you want to face, right? And then you take this rotator and you just always rotate your thing by that amount. Oh, you can't? Yeah. You can also do it pretty easily with the particle system. Material to do it. Maybe some hacky world position offset shit. I know you could do it with ray marching, but that's a rabbit hole you probably don't want to go down. Because you could do anything with ray marching. So with this definition, we could have a star system that has some number of stars. It has some number of planets, some number of asteroid belts or clouds, some number of local nebula volumetrics. Eventually we would need to add things to this, like, or actually we can do this now. Has warp gate. And the great thing about doing it this way is I can define everything I want. Like, I can define structs for everything that I want to eventually be in it. And then I can just go make them one at a time instead of, like, kind of... It gives me a good picture of, like, where I'm going. I don't know how keen I am on the stars being multiple per system, though. It just seems like it's going to be a headache. Obviously, we have multiple planets, asteroids, nebula, and space stations, but I'm only going to have one star parameter array. Or only one star parameter per system. I was just, like, envisioning, like, doing orbits and doing, like, placing all this shit, and then I'm like, oh, but if you have a second star in the picture, it just fucks everything up. It makes everything, like, 10 times harder. I wonder if my GitLab for work is still down. Yep. I guess I don't have to do work today. GitLab's down. Oh well. And also, like, I was just kind of putting everything everywhere. I'm trying to be, like, much more organized this time around. I'll go ahead and save everything here, and I can show you some cool shit. So back to the other project for a moment, because this was cool. Man, is this already toasted? Shit. So I don't remember if I had it still working at the end of the night after fucking around with it, but let's see. Not working at all. instead. Why didn't it work? File. Perfect. I was trying to figure out warp dispatchers, that's why. Or I was trying to figure out event dispatchers. Oh, great. Now it's fucking permanent. Yeah, the custom input code, I'm assuming you could probably do it with that, because that is just fucking C, and you could do whatever. You could do the thing where you escape from the, like, this is wrong. Damn it, I wish I hadn't been in the middle of this refactor. Start warping, true. This needs to bind to this. So it didn't actually warp me, but that is what's supposed to happen. Hold up. I'm gonna get the warp done real quick and go back to the other project, but I did want to see this. So that's... here, I think. Change system. It was like... yeah, it's like, it's good enough for now. So let's see. I think this should just work now. We're in a new system. There's a little lag there. And a new system. But like, I could fix that lag. I know how to fix the lag. It requires me to divorce the skybox from the solar system, and it requires me to make it so that I can change that material in real time. I'm gonna find a star eventually. There's one. So I got at least this part sort of done. Like, it's not what I want it to be, but it's like good enough for a placeholder to where I'm not like Oh man, I really wish there was a transition here every time I fucking change systems. My sphere noise, so like I learned some stuff doing that texture that I can go back and make my sphere noise generator better, but basically I've been using these packed textures. They're like you render noise in the red, green, and blue layers, and then you can extract 3 different kinds of noise from a single texture. And I've been passing them in as texture samples, which was wrong. I should have passed them in as texture objects because that allows me to split off texture samples to do things with the individual layers, like do UV tricks with the individual layers. So it's going to give me a lot more randomization when I go change that stuff. Yeah, like if I get my sphere noise generator, so these are inputs right now. Oh, and I have to stop playing the game. Wait. Oh, okay, whatever. So you end up with these textures that look like this. And this texture actually has 3 different noise textures overlaid on top of each other in the red, green, and blue channels. And then if I was to do something like this and set this to one of those noises, say I was to set this one to this, right? At that point I can do this, plug this into each one, and then I could do text coordinate equal to, this functions as like an offset, right? So, and now I can do this, and now we can take this, do it 2 more times to these guys. And the reason this is good is because it lets us control the individual channels at different locations. So now I could then say, okay, you're going to be at 0.1 or 0.2, 0.2, 0.8, or let's do 0.7, 0.7, 0.7, and 0. And then I could do something along the lines of although you would never want to do the y-axis actually, because they're spherical. I just saw it on, like, I was watching like a guide, and I was like, oh, that's cool. Alright, so this just looks like some noise, right? It doesn't look that fancy, but what you got to realize is that when you randomize these numbers here, it will completely change the noise pattern you get. To different patterns. Because they're like, each of the noises under here are, and then you can also do things like, if you don't like the way that blend looks, you could do blend difference, for instance. we can diff it 3 times, and that's going to look completely different. And then if I change this value again, it changes the texture. If I change any of these X values, it will completely change what the actual texture looks like. And that gives you like all kinds of crazy randomization on these different paradigms. So I'm going to redo this again, but not like, it's not actually that complicated of a class. So it's not that big of a deal. Rather than, like, I think I can probably cut 2 of these textures out and still have a higher complexity because these will both split into 3 each. Another fun thing you can do is then, let's say you wanted to make a color system for this. You could add 3 colors and multiply them by the individual channels and then combine them and then multiply them by this. I might have colors already. Yeah, I do. So let's just multiply actually this is this one. Well, no, I guess it doesn't matter. Multiply so now I've masked these with the channels, and then I can just add so now we have like a color map with our 3 colors that we picked up here, and then we can just say multiply again like this, and we get something like this. Pretty cool, huh? And because it's all spherical noise that's made to map to a sphere, everything just lines up right, and I don't have to worry about end caps or anything. Bro, I turned around, there were like 2 messages on my Teams, and I hadn't checked it in like 2 hours, and I was like, oh shit. It always freaks me out a little bit, but then it was like people telling each other happy birthday. And the great thing about this is we can completely change the output. If we pick different noise textures, we get different outputs. So I think maybe instead of 4 inputs, I'm going to have 4 texture inputs to this. I'm going to have 3, which will give me 9 textures of noise to work with. And you can still do stuff to this too. Like if you want more fall off, which you would, you can add a power node. And make some more fall off. If you wanted to say, to have variation, like, because right now I've constrained it to the same color channels that are driving the opacity, but let's say I didn't want it to work that way, then I could do another texture sample, and instead of multiplying by the transformed texture locations, I could multiply by the original ones. And then we should get some color shifting in the actual, inside the actual nebula themselves, because now the colors aren't translated. Let me take this back down to a 1. So there's all kinds of stuff you can do with this pretty easily. And And one of those things is going to be the ability to build planets. Because all you need is the right noise, and you can figure out different ways to combine it till it looks like a planet height map. And then you can feed that into world position offset and and then figure out a way to make it have planet-like colors and feed that into the colors and multiply them just like we just did. And then you got a planet or a star or whatever. This is going to form the core of a lot of the rebuilt stuff. It is fun to be able to just warp around. My warp refraction bubble is starting out visible for some reason. I didn't turn it off, I guess. But this is like an effect that's really supposed to only be there when you're warping. Eventually, you'd be able to rotate around inside the warp bubble too. Like, I wouldn't bind it to the player rotation, only their location. And the front end of the warp bubble is blue, and the back end is red. For like blue shift and red shift of you going really fast, everything coming at you is getting shifted to blue, and everything you're leaving behind is getting shifted red. And I would follow that same paradigm for like a tint overlay for the universe I was moving through or something. But okay, so this is all clean and locked up. The other thing I did was I started it as a C++ project instead of a blueprint only project, just because I don't want to be annoyed later when I want to do C++ in it. All right, going back to the re-arc. Oops. Shit. Clean off my gamer desk a little bit. All right, let's pick it back up. I'm gonna go ahead and transfer all my sphere noise and planar noise over. All right, here we go. Now, I wanted to go ahead and content drawer. Noise. Noise. Can I do like this? No. That's fine. We'll do it like this then. I still have about 10 more different types of sphere noise to render. I just had enough to work with. I still need to render all the uniform. I still need to render uniform at 100, 200, 400, and 800 resolution, flip them all. But, and I need to render a bunch of the others at 50 and 25 resolution, but not today. I'll do that when I'm wanting to just like watch TV or something. Yes, I would like to import them. So there's a gig of noise textures or so. And then I'm going to go fetch my planar noise textures, and I'm going to probably get rid of all the noise I've rendered that's not followed my very specific workflow for making the multicolor noise. It's just, with noise like this, you generally don't need the color channels. And it's so much more efficient to have 3 noises in one for a given render, because it's like you don't need 10 different noises at the same resolution. You just need one. Well, not 10, but 3. And then to get new noise, you can just invert it, and then you have a new set of noise. And then you could also flip, or you could flip it on either axis or both axes, and that's new noise. It's just like, this is the way to do it, I think. The idea is like, you can make pretty much anything with layered noise, but you have to figure out how to combine it all together. And rendering the noise is expensive, and it takes a long time. But if I can pre-render a wide selection of different types of noises, then that's almost as good as being able to generate it randomly from a seed at runtime. It's not as random, but as long as you're combining enough shit together, it's going to feel pretty freaking random. What else do I have today as far as meetings? I think it's a light day. Yeah, nothing, just a virtual social hour that I'm not going to. Hit me up when you guys start meeting back up in person and going to restaurants that serve good food, and I'll be there. I'm not going to virtual social hours. That's just like, it's such a dumb idea to me. If I'm going to a work event, I want free food or entertainment of some sort. Alright, there's all my sphere noise. No, textures, noise, planar noise. These are just placeholders. I'm gonna render like I eventually. So, the way I've named my shit here is not really very good, but the way I've named it over here is actually pretty good. So you've got the type of noise, the resolution, and an inverted flag. So this is 100. This is noise that's rendered at 100 width with not inverted. This is noise that's rendered at 100 with inverted. And we have those for 100, 200, 400, 800 for blur noise. 100, 200, 400, 800 for filament noise. These 50s are what I need to add to these two. 50s and 25s. Everybody needs 50s and 25s. But for turbulent noise, we have 100, 200, 400, 800. And for uniform, we only have 25 and 50. So I want uniform 100, 200, 400, 800. And everybody else, I want to have the 50s and 25s. And then this will be a full set of all the different types of noise that are useful for my purposes. Once I've got that, I want to go over here. And I want to render the exact same noises, but as tileable planars instead of sphere noises. And then I'll have a master library of noise that's diverse enough for me to do pretty much anything with it. But rendering the noise is not a engaging process. But if I'm being truly honest with myself, if I'm re-arcing the project, it's probably something I should complete before I begin like actually making stuff. I can define the architecture with structs all day long. What a beautiful library of texture this is. Blur noise, filament noise, negated filament noise, turbulent noise, negated turbulent noise, of all different resolutions. This needs work though. Actually, oh god, I don't know if I want to go down the... I wish there's a way for me to automate the process of rendering the noise beyond what I already have, because I always do the same thing. Can I make a macro in GIMP? Probably not. It takes too fucking long. That's the problem, is it takes a fucking long time to make these. Like, to make one of these high-res ones, these 50s or 25s, it's literally like an hour to make one. Maybe Photoshop would be faster. Didn't that go free for everybody? Photoshop probably doesn't have the noise plugin for Photoshop. Best photo noise? No, not that kind of noise reduction. Noise procedural noise plugin for Photoshop. Because the big thing about this workflow is that I can generate spherical noise with it. Like, that was huge. Being able to make it so that I don't have to like monkey with the texture or put end caps on the spheres or anything. I guess what I should probably do is, while I'm doing the re-arc, I can render some noise. I want to complete my sphere noise set, which is unfortunate because that's the one that takes a long time. but I can show how to do it. This would be an example of something that's not finished. So what did I need to just... So I use this plugin. It takes a long time, but it does spherical, which is huge. Yeah, there's a lot of jank. There's a lot of jank like that. It seems like I think that in like a year or two, it's gonna be just so sick because they'll work all those bugs out of it. I want them to give more like robust C++ integration with the materials, and or just straight up let you put GLSL or whatever the other one, HLSL or whatever the fuck it was, code just straight into it. I want them to give us a way to pull in like shaders from either DirectX or the other one languages in like the native language from somewhere else and just stick it in there and have it work. What? So I know I want like the max number of octaves. Hurst at like 2, 3 maybe, 2.25. Okay. So 100 by 100, uniform noise. Go. The good news is that this is the fastest noise. So we let that churn. Once I have a complete set of these will be much faster because they're 4K textures and these are 8K textures. I'm using 8K textures for the skyboxes. But for the stuff that I need 2D noise for, I generally don't need 8K textures. So the way you do these is you make 3 layers. You make RBG, you make this additive, additive, additive on the layer group. You make a full red, full blue, full green layer, and you make them multiplicative. And then you make normal layers on the bottom of that, and you render your noise in the normal layer. And once you've rendered 3 layers of noise, you create a new layer from visible, and that's going to snapshot the window. And then generally I run a curves on it, and then I do a stretch contrast, and that's my steps. Because you also want all the noise to be in like similar value range. Like if you averaged every pixel in the whole image, you would want them to be like pretty close to each other. Because anything too dark is going to get washed out in the mix, and anything too light is going to dominate. Pretty sure I said it's sphere noise. I hope I did. This is like, I consider this like a part of the tooling or like the main engine of this game, because like 95% of the way I'm going to be building stuff is going to be with this noise. I can use it for every star, every skybox, every planet, every moon, any spherical space body, basically. Asteroids will be different. Asteroids will probably be nanite, like an array of nanite static meshes, maybe like 20 or 30 of them. And then I'll just spawn shitloads of them. So we go to the next layer. I don't change the settings, but I do change the seed. You don't have to change it multiple times, just kind of have it. You could do the same effect in probably other ways too. Is it like a painting where the eyes follow the player or something like that? Is it that kind of thing? If you know what WoW mounted is, I could just look up the WoW mount. Nether Drake Elite. I'll take a look. I played WoW for a long time. I think it's pretty shit right now. Nether Drake Elite. Yeah, I'm pretty sure I had this. So, is this it? It has the same eyes. Do you just want like this emissive glowy eye effect? Or do you need it to be like actually like looking, like if you got up close to it you could see where it's looking? Because you could literally probably just do this with an emissive texture. Yeah. To do that you just multiply the color by some arbitrarily large amount. Like, let me find a texture. Or I haven't made any materials in this project yet. Shit. So you can any texture or material that has the emissive color, don't hook into the color property. Have your output hook into emissive, and then how bright you want it, just multiply the output by a number. So you pick a color and you multiply it by a number, and that's going to determine the brightness of the emissivity. So you can do that in any material output type that has the emissive color property. Because I use that quite a bit in this project. You don't have to do any kind of like moving textures around or anything. You just make a sphere and have it glow like that in the spot, you know? And if you want an eye on it, you could still have a glowing eye, but then you have to talk about like the look at direction type stuff. Let's double check my chat so I make sure that I don't have to do anything. All right, great. Yeah, absolutely. And then you just stick it like it literally it could just like I'm gonna need emissive anyway, so why don't I just make, actually this is perfect. I can show you how to do it. Yeah. You just, yeah, that's about right. You just vector parameter color, multiply, scalar, yeah, I gotcha. I actually need an emissive material anyway, and then normally I just make the material surface opaque, unlit, or additive, depending on how you want it to work. Wow, that's... oh, yeah. Makes sense. Right? So, for a dragon's eye, like... seem to be about there. I needed this material anyway because I'm going to need it for lots of stuff in my project, and having one here is fine. I actually want to do... do I want to... I don't... I want to keep my material instances separate because it's annoying to me to have to slog through them. But I named this folder materials, which wasn't a super great name in hindsight. I almost want the instances on the outside. What do I call this? So like... I get hung up on shit like this. I don't like the naming. I don't like having a materials folder with materials folder inside it and a material instances folder inside it. But I don't know what to call the folder that holds materials and material instances. I guess... better than nothing. Because I want to keep all this stuff separate because everything gets like very clusterfucky very fast. And I'm going to have subfolders in these for like individual textures for individual things. Jesus, what the fuck? Oh yeah, I forgot. I'm eating memory over here too. No wonder it's running like shit. This image is 5 gigs in game. But when I'm done, this will let me pack 3 8K spherically wrapped noise textures inside a file that's about 50 megs or so, which I don't think is too bad. Yeah, I'm trying to follow a more structured approach. Like I said, I kind of just threw myself into it and started learning it. So I didn't like it's a long chain of experiments and failed experiments and like not understanding something and then understanding something and then everything is like slightly better after that point. I don't know what's going on. Boom. Alright. Exactly what I wanted. Now I can keep that shit separate. I really don't like having the materials mixed together with the instances. I want them in separate folders for sure. I almost do the post-processing steps of this. I watched like almost 2 entire seasons of a TV show while rendering all this noise. I just had the TV show on my main screen and GIMP on the other screen, and every 10 minutes or so I'd click a button, and then after you click a button like 4 or 5 times, you have output. So then I usually do this. No, 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 no. No, 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 wrong. It's okay. It's okay. It's gonna come back. Have faith. Okay. You can't do what I just did and do curves before you do this. All right. No, no, no. God, I'm forgetting like everything. Wrong, 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 wrong. Now you do curves. So I take this handle, I put it like near the base of this, and I take this handle and try to go with the intercept on this line and make an S curve that looks something like that. And when you do that, you should get 3 like very distinguishable different color patterns. And then export that to, let's see, here, 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 here. Uniform 100 0. And you don't have to make the ones, like, you don't have to make the underscore ones immediately. But you make those by just reopening this file that I'm exporting up back into GIMP and then inverting it. And then this takes a long time. Oh no. Nope. It worked. The smaller the noises, the longer this process takes. This feels a little too bright. Just looking at the others. This one might need to be curved. This is really nice to have them all in the same place like this because I can have them like isolated by themselves without other stuff mixed in. Go look at them all. Figure out which ones are out of sync with the rest of them. This one, maybe this one, maybe this one, here, 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 here. All right, come on. Okay. This is gonna be really nice. So we got all these boys to fill out. I need to be systematic about it. I think I have quite a few. So let's just go in alphabetical order. So did I make types? Hold up. What? Yes. Import. It's not quite as bad as it seems because all the O1s are just derived. Alright. Yep. That's the one. And then back over here, we just... Shit, no, not like that. You have to recurve it. So basically, after you do this once, you only have to do the post process again. We invert. I fucked up. Damn it. Oh well, I can fix it. Filters, colors, curves. Yep. Belt like this. I forgot to stretch contrast on the last one, so I'm going to have to open it up and do that. But these textures are super fucking cancer to work with. At least when you're building them. Once you've got them, though. I don't mind sinking the time in because they're fun to play with once you have them built. And then the other thing that I've been doing is this right here. This automatic, it like normalizes the color channels to between 0 and 1. Normalizes their range. Yeah, some guy had a birthday, and so now, like, my shit is fucking blasting. Yeah, so this is how I make the noise. I have some noise, like my set of sphere noise isn't. No, like my chat, my work chat has like it keeps getting like tons of messages because everybody's saying happy birthday to this dude. But yeah, I'm going through my process for generating this noise. And I'm generating the missing parts of my noise collection. I don't have all of it. Yeah, exactly. And I'm just doing the post process here, but I forgot to do it on the last export, so I have to load that one and do it again. Yeah, well, the important thing is what it represents. I mean, it represents the ability to put. Yeah, it represents the ability to put three 8K grayscale noise textures into a file that is between like 20 and 120 megs. Yeah, it's actually not that hard to make either. You just do this layer structure and you can make it. It's like layer group, layer group, layer group, additive, 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 multiply, 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 render noise, render noise, render noise. And I just do three of the same parameter noise, but with different seeds. But I have this library that I've been building up, right? And the only thing it's missing in the large scale noises, what I use the most commonly, is this uniform noise 100, 200, 400, 800. So I'm trying to complete that. In reality, I need the small versions for everything too. Yeah, and that means that like it's super cool because like say you want to do something crazy, right? And you're going to use all 16 of those textures with RBG noise. That's fucking that's 32, that's 48 textures. Your fucking computer would catch on fire, but like that's 48 texture samples. Can you imagine trying to work with 48 8K texture samples? I think I'm going to do three for my noise generator. I'm going to do three inputs. Probably like a low res, a mid res. I mean, yeah, it takes a while. This is just the export too. It's because like, okay, so this file is 6 gigs in GIMP, right? But the output file is like between 20 and 150 megs, depending on how much compression it can do. So for it to go from a 6 gig GIMP file down to 50 megs, just imagine how much compression it's having to do. Yeah, yeah, yeah. It's like, but even so, this is like, I feel like these assets, these are like triple A ready assets. Like these noise textures I made, you could use these to do all kinds of shit. And once you got it, you got it. And you don't need to be able to have like actual procedural noise if you have enough pre-rendered procedural noise. The sad part is I have to open UNF 100 and then I have to do the fucking stretch contrast on it and then re-export it. This guy. I didn't stretch his contrast. Yeah, because you're taking like each of the grayscale layers and multiplying them or differencing them or doing things like that with them with each other, and they'll like when you move the white parts, they mask out different parts of each other. So if you have a couple of them layered and you just change the UVs offsets a little bit, you get different patterns. Eventually, I'll need some like RBG craters and like mountains and shit like that to be able to overlay on top of the to overlay on top of the planet generation. Because I've already seen this like right now. I've mostly been using this for nebulas, which involves putting them on like transparent surfaces. But I've seen in that process this make things that look like they could already be used as planets when it's not transparent. And you can take any of the height maps or the combined height map and you can plug it into the world offset and get like actual get like actual like height on your terrain if you have a dense enough sphere. I don't think you can world offset nanite stuff, which is kind of a pain though. Okay, so we did this. Delete you. Then I need to file open. So 43 megs was the output. You don't. But for my purpose, I'm going to need a pretty dense mesh because I want to use basically like a material height field on it. And so it would be cool if I could use nanite for that because I could like kind of put infinity polygons into it. I think you could use I think there's something called a virtual height field mesh that can do it. I think I did something with that when I was studying when I was working a different project. I don't know if you can wrap it on a sphere though. I only know that they were using it for like actual local landscape offsets. So like it wouldn't have collision, but it you could do things like pebbles and stuff on the ground that were 3D. They just wouldn't have collision. Pebbles are small rocks, cracks in the ground, stuff like that. They use it for snow in some games. You know how the effect in like Red Dead where when you go through the snow it like fucking I don't know if Red Dead was Unreal or not, but it's a similar concept. Yeah, you can. Yeah, exactly. Or like if it's deeper, like a trail left through it, it's a virtual height field mesh. And they have like some kind of logic to like clamp it to the like lowest level when the player's like walking through it or some shit, you know? Yeah, I don't know. I don't know. I haven't done enough research on that to know. The only thing I've done with the render target was the skybox thing, which I'm gonna have to figure out. I know I still want to do that for nebulas, and it works fine for nebulas because I can warp between them. But it's not gonna. I'm not gonna be able to warp between different star positions. I'll use render targets for my save game icon. I use it for the. I use a render target for snapping the cube map from the stars and the nebula, and then hiding all that shit. Yeah, for like a cube, it's a cube camera. And then it renders to a texture that's used in the skybox material. So yeah, it was like it was really finicky. Like I was calling capture scene, and it wasn't working. And I found out that like if you don't call set render target before, even if it's set on the cube camera, it wouldn't take it when I called capture scene. I had to in the blueprint set the render target to whatever it already was, and then call capture scene. And then the next time I want to snap it, I have to do the same thing again. I can't just call capture scene again. And like I'm like, why isn't this working for a lot longer than I would like to admit? I'm gonna go get my water. All right, and that's one of the 4 I need. Let's go ahead and do this. So now we just kill this guy. Go over here. Wait for my computer to choke. Delete this layer. Go to this layer. Filters. Reshow. No. Shit. Fuck. Oh, and this one takes a long time to show. Close, please. No, I believe in it. I believe in GIMP. It's not really dead. This is what I'm going to start doing. I'm going to start running GIMP and doing these on one monitor. And then I'm going to start going left to right through my structs that I've put in so far and defining some parameters. 200, 15.225, that's what I rendered that with, so we're good. Everything's good. Hit OK. Let it churn. Let's actually put that over here. And then come back over here. Go to, I actually don't need this open at all. Structs, cascading layer parameters, asterisk parameters. Classification. Yeah. I'm thinking, what else is this? So this is a local. So for rings, we can control it with radius and rotation. And for clouds, we could also control it with radius and rotation, I think. Scale. Okay, that should be good enough for now. Let's do 2 for now. Um, okay, there's that. Oops, fuck. Yeah, okay, that's how I set it up. I've already defined some of these. Eventually things like noise will go in here, but I'm like so far away from developing this. I'm just trying to get some core stuff in. Need lots of these, so have temper. Planet types. I could take the Star Trek classification scheme. Do I just use this list from Wikipedia? Let's do that. Oops. I'm removing theoretical from all these, because if I'm putting them in a game, they won't be theoretical. Damn it. Hey, Jinx. Hey. Hey. Hey, buddy. Layer, new from visible. Rendering another noise. Gimp is choking. Jinx, I wish you would stop doing that. Please stop doing that. You have like all the scratching posts in the world. Why you gotta tear up the carpet? Here, come here. How about this? Post processing. Oh, I can't believe you're just sitting here, Jinx. You almost never sit here in my lap. Hey, buddy. Export UNF 200 0. My goodness. Alright, you free. You free to go. Jinx, stop, dude. Come on. I'm gonna throw sock at you. Okay. Back to this. All right. Got some starting planet classifications here. Okay, and then back to structs, planet parameters. Radius is definitely 1, but classification is also 1. Planet classification. Did this finish? It did. Stretch contrast. Okay. File. Damn. Export. Now we're exporting in a second. Radius. Classification radius. Nice. Okay, one down over here. Delete this layer. Because each layer takes up like a gig. Colors, invert. I think I want like atmosphere details here too, so like, but I need an enum for that. And in like grade school level solar system research that is actually kind of fun. For now, I'll just say none. Did this finish yet? Almost. There it goes. I just gotta stretch contrast again. On the stretch contrast. You know those games like QWOP or shit like that. You could make a game where people fly on dragons, but like the dragons don't fly like dragons. They just fucking chaotically fly through the air like they've been like thrown like from a catapult, and they just fly like that. Like, no, that's just how dragons fly, bro. And you're like, how? The dragon looks like it's just been whipped across the stage from a rope. And they just fly like that. It's like the tumbling goats in Elden Ring, sort of. And nobody they could be like heavily involved in like the flight transit services of the civilization, but nobody really wants to write it because you just get sick. I'll just take the fucking. I'll take a carriage. Meanwhile, in the background, some dude takes off screaming from a dragon that's just like fucking flipping through the air while it flies in like a chaotic direction. I think that a lot of times that kind of shit is good at indie games. Where like it's like if you don't have the capability to make something that's like triple A, at least some that you can make something that's like shitty in a funny way, you know? Shit, you could just have one dragon NPC character, story character, who's like super dumb and he flies like that, and all the other dragons fly normal. Alright, stretch contrast is done on the next export, so let's set that up. Export as UNF 201. I only have 2 more layers to go of this, and they export faster as they get bigger. Or wait, no, I think they export slower as they get bigger, actually. They export faster as they're smaller, but the file's bigger. I want to fully complete this set of noise for the sphere noise, and then after I get done with that, I'm going to need to do the planar noise, but the planar noise would be like 4 times faster. I think it's exponentially slower as you go up in resolution, so an 8K by 8K takes 4 times longer than a 4K by 4K. What? What? What does it matter? Oh no. So where's the new one? These two are new. This one's new. I'm trying to export, but I might have crashed in GIMP. For real this time, maybe. I think I fucked it up. Cancel? Oh no. No. Alright, well. Shit can GIMP. Yeah, exactly. Okay, well, I can semi-recover. Maybe. I don't think I saved the template, unfortunately. But worst case scenario, I can. Yeah, I did. Worst case scenario, I can load up the 200 that I did and do it from that. Image. Colors, invert. And I gotta curves it again. Stretch contrast again. Colors, curves. Gotta figure out what I want for dinner tonight. I want something good. Either make something good, go get something good. Stretch contrast. You can make it like a trap. Like you go up to the, you start the game out early. You got 500 gold. You go to the mount vendor. There's one mount that's like 50 gold, and then all the other mounts are like 200 gold. Export as UNF 201. Yeah, just pay for transportation. Like, he's free, but you gotta come pick him up. And to do that, you make them walk a really long way because they don't have a mount yet. And then when they get him, he's shitty. You know what it makes me? Oh, I know exactly what it. I know exactly where the mental image came from. It just came to me. I don't know. Have you seen Smiling Friends? Anyway, the episode in Smiling Friends where they encounter a witch and she flies away on her broomstick, but she's just fucking like flipping and like tumbling through the air as she flies away, like cackling. That. It occurs to me that I'm streaming and I have the ability to show these things to people.
You kissed your dad in the mouth?
What was that? Oh, this must be a witch quest. We can.
This.
What was that? Oh, this must be a witch quest.
As she flies away tumbling.
This actually sticks to my life.
That one.
That cannot be allowed. How is that fair? How is that even fair?
This is kind of a bummer. This isn't right. Colors, curves. I have to get it in like the similar ranges to. Just bring this down. No. I don't want to have to re-render all that noise. It is a little too bright though. All right.
You kissed your dad?
Found it. I found the one that I was thinking about. This is exactly the one that I was thinking about right here. It's great. He's upside down in this frame. Well, that one's not perfect, but it'll be good enough. Up comes GIMP again. Now we do our 400 and our 800. So another thing that I learned about the other day is that you can re-origin the world. So you could do something like define an arbitrary boundary, and when you cross that boundary, swap the world origin from like way far behind you to way far in front of you and stuff like that. Which is going to be important, I think. Alright. Those you discard. Filter. Render, film image noise. Lattice noise 15 octaves, 0.25 hertz exponent. Output is spherical. Lattice noise at size 400. Go. Bigger noise renders faster too, which is kind of nice. And while this is going, I'll go fill up my drink. So I now have blur, uniform, filament, and turbulent noise. When I finish this set, I'll have all of those in 100, 200, 400, 800. Then I need a bunch of 50s and 25s. But those can kind of wait. They're a little bit more niche. And then I need to do the same in 4K tileable planner textures, but those won't take nearly as long. It's a lot less painful working with the 4K textures because, like, when you're working with these, you get crashes a lot. It's just, like, overall unstable because it's so big. And that forms the core of most of our ProcGen texturing and things of that nature. The GIMP devs, I mean, like, we'll be on 16K textures soon enough, man. I do have 32 gigs of RAM. So, like, I don't think it's my video memory. Yeah, no problem, man. Yep. I might actually just shut off the stream and watch some TV and render some noise. Try and build up these sets. I kind of want these in place before I start dev on the new project, because they're, like, intrinsic to a lot of the things I want to do. And having the full tool set from the start would be really nice. Maybe I'll run through and do all the 4K textures today.